Welcome to everyone that is joining us today for today's Ocean Wise Awards Lecture Series, Part 4 today. And we're so excited to be talking about the underwater soundscapes of British Columbia with you. We'd like to start off our program by saying how grateful we are to be teaching, learning, and living on the traditional territory of the Musqueam, Squamish, and Tsleil-Waututh people. It is from learning from and with them and incorporating best practices of looking after the land that we are living on that we can offer the best quality programs through conservation, research, and education like this one today. Without further ado, I'd like to welcome our host today, Dr. Peter Ross, to introduce our awards and our presenter. Over to you.
Thank you, Danica, and welcome everyone. Delighted to be here again at this unusual online rendition of our Ocean Awards. We've been doing this for a few weeks now, sharing each and every one of our award winners with an online audience. So this is an exercise, of course, as we pursue this COVID-19 adventure in this unusual year 2020. My name is Peter Ross. I'm Vice President of Research at OceanWise. And delighted to be hosting today's event. The Ocean Awards have been running since 1995, inaugurated in that year as an honor to our founding Executive Director, Dr. Murray Newman, at the time. So that makes this the 25th Annual Ocean Awards, 25 years. We're delighted to be here with you. And to share in this historical rendition of our Ocean Awards. We'd rather have you here in person, but this year is a little bit different. And so we're going to celebrate as we pursue this day's event by introducing this year's winner, Dr. Tom Dakin, for the Conservation Technology Award. And as many of you can imagine, conservation is not very potent without knowledge and understanding and data and wisdom. And nowhere have we seen more exciting inputs into the realm of conservation than the application of technology in the service of understanding and protecting the world's oceans. So delighted to have Tom with us here today to accept this award, basically, and share with us on a topic that is of supreme importance in terms of marine mammals and other species in the ocean, and that is for his work on innovations in support of understanding underwater noise. And underwater noise is very topical. It's topical in Vancouver, it's topical in the Strait of Georgia, it's topical in the Salish Sea, and it's topical around the world. So Tom, we are delighted to hand the microphone over to you today to provide us with insight into your personal and professional journey on a topic of much value to us all here at OceanWise. Thank you for joining us. Congratulations yet again on this award, and we're delighted to have you today. So over to you, Tom.
Well, thank you, Peter. I hope the audio is okay here because I just dropped out my headphones. But okay, I'm going to share my screen and start on with the presentation. And thank you, Danica. Thank you, Peter, very much. For the award, but also the chance to chat here with some folks. Okay, so. Hopefully you can start to see my screen now. All right, so I'm going to spend about 20 minutes talking about underwater sounds in British Columbia and a little bit about some of the people that are gathering some of these sounds, in particular the BC Coastwide Hydrophone network that I've been working with for a while. All right, so I'll start in just before playing any sounds by saying there's a number of forms of energy that can be used to look at the ocean, to understand the environment, and to be used by humans and animals for viewing their environment. You can see here some plots of how far different colors of light can go down into the ocean. These are in 50 meter intervals, so not very far. And in coastal waters like we have here in BC, it's only a few tens of meters, so it's not very good using visible light in the ocean. But sound is another story altogether. You can listen over very, very long ranges with sound in the ocean. In fact, one researcher in Chris Cornell was listening in Virginia in the U.S., and he was listening to blue whales in the U.K., so across an entire ocean basin. So sound is incredibly important and effective underwater. And for this reason, marine life has really evolved to take advantage of underwater sound. And for most marine fauna or marine animals, it actually is their primary sense, like vision is to us, sound is to them. So I'm going to give you a couple examples of some local species that use sound in the environment. And these are some of the different uses that animals have for sound in the water. So here's a picture of some Pacific white-sided dolphins. I'll play a little clip of them. And they use it for sound for communicating, for navigating, for finding food, and also for helping them to avoid predators. And so this is what they sound like in the water. And so hopefully that came across fairly well. Peter, if there's an issue with the sound, let me know. Okay, so another animal is the sperm whale, another local animal. This is a very specific sperm whale. Jared Towers took this picture of this sperm whale called Yucasam in the Strait of Georgia. So this is the first time in 34 years that a sperm whale has come into these coastal waters like this, so it's a really good sign, and we're all pretty happy about it. And this clip that I'm going to play is actually this particular animal. This is Yucasam. And they use those clicks to see their environment, and they also use them for communication as well. Now, sperm whales have the largest sonar system on the planet built into their heads. As humans, we haven't built one as big. So it's pretty astounding what they have. And one of the interesting things about it is that they can produce such high intensity sounds that they can actually stun their prey. They're not the only animals that use sound to stun their prey. Pistol shrimp, for example, use sound to stun their prey as well. So here's another local species, the plainfin midshipman, and I'll play a clip of just one of these things making a sound here. So that's one fish. Now imagine being in a bay where there's thousands of these fish, all humming like that to attract mates. And you can hear that sound above the water. In fact, some people have complained that even in their house, with their windows and their doors shut, they can still hear these fish. So it can be pretty loud. Here's another local species, the humpback whale. This particular whale is named, that I took this picture of, is named Potter. I'm a Harry Potter fan, so it's kind of my favorite whale. But up here you can see 4 different spectrograms, of one for each hydrophone. This is in a box array up around near Hartley Bay that Janie Ray's group is recording whales on as we speak. And this is a cool recording that she just sent me. It shows up on all four hydrophones, and that allows us to actually triangulate exactly where this whale was when it made this call. But this call's cool because this is the first of a series of bubble net feeding calls that Janie has recorded up there that are new calls that in the 20 years of recording or listening to whales up there, they've never heard these particular kinds of bubble net feeding calls before. So they've been hearing these calls for the last couple weeks now, and it's quite a departure from the normal bubble net feeding calls. So they're pretty excited about it. So one last thing on the uses of sound by local animals, and this is for warnings. So we can see here sort of the quintessential one for warnings. We've got Biggs orca, or transient killer whales. And these whales are marine mammal eating orca, and they eat sea lions and seals and dolphin and porpoise. And all of these animals are smart enough to recognize the calls of Biggs orca, and they'll get out of the area as quick as they can when they hear these things. But the whales are really smart too, and they know these animals can hear them, and so when they hunt, they typically hunt in stealth mode, and they try and sneak up on these animals. So this is what the Biggs orca sound like, and this recording is from when this picture was actually taken. So there was 34 of those animals there at that particular time, all having a bit of a party. And this is what a sea lion sounds like. So this recording is from Ocean Networks Canada's hydrophone at Folger Passage, and it's 100 meters below the surface, and the sea lion is up at the surface barking. And it's a really clear recording, so you can see just how well sound propagates in the ocean from this recording. That's 100 meters below the sea line, so it's pretty impressive. So animals make sounds, but they're not the only ones. Weather makes a lot of sound, like the wind, breaking waves, and rain and snow. They all make sound in the ocean, but humans have a huge impact on sound in the sea. And there's industrial uses of sound, and there's research uses of sound. I won't go through all of these, but sound is our best tool for examining the ocean. And so we pump a lot of energy into the ocean in order to study that environment and to exploit that environment. Sonar systems, for example, are just one example of that. But we intentionally put a lot of energy into the ocean. But we also put in a lot of unintentional sound energy into the ocean, and here's a few examples. So recreational boating, when you go out in your small boat, you don't mean to put a lot of sound into the water, but you do. There's sound coming from your motors, there's cavitation from your propellers, there's your echo sounders looking for depth below your keel, there's fish finders looking for fish. Low-flying aircraft are another source of unintentional noise. Construction, some of the two biggest ones are pile driving and dredging. And shipping noise. This is the worst one of the bunch. Shipping noise has been doubling in intensity every decade from 1965 to 2005. And it's been increasing after that still too, but not quite doubling every decade. Except for this past year. And this past year, we've seen a drop in shipping and a consequential drop in noise. So it provides a really good scientific opportunity for us studying sound in the sea. And you can see from this map, this is just the large commercial shipping around the world. And you can see where it's concentrated on this map. So we'll zoom in on the British Columbia coast here, and you can see from this map where the hot spots are for shipping. Again, this does not include the small fishing boats or the recreational boats. It's just the large commercial boats. And you can see in the dark red areas around here, if you look at the color legend here, that we're talking about thousands of large commercial vessels for every 5 square kilometers of ocean per year. So these are very, very noisy areas where it's all in the red. And this is an example of one ship. This happens to be a container ship, and this is what it sounds like underwater. So pretty noisy, and you can hear these ships. It's quite, I often hear them 65 kilometers away. So when you think of that, how far this noise propagates underwater, and you look at this density map here, you can see our coastline is pretty noisy. And I wanted to say a little bit about where that noise comes from. So most of the noise, not all of it, but most of the noise comes from your propeller on these boats, the small boats and also the large vessels. And it's caused by cavitation. Cavitation is just like boiling water. So when you boil water, you take the water and you heat it up so that the vapor pressure of the water goes above the ambient pressure around it, and the water will start to boil. It'll convert to steam. You can also convert water to steam in a different way. You can lower the ambient pressure so it's below the vapor pressure of the water, and it will create steam as well, and that's called cavitation. And you can see that in this picture of this propeller. If the propeller moves fast enough, the water can't rush around in behind the blade quickly enough, creates a low pressure area, and it creates steam behind it. And then once those steam bubbles come off the propeller, they will actually implode once they get back into the higher pressure area off the propeller. And when they implode, it's like a miniature explosion, really, really energetic. And you can see on this stainless steel prop at the bottom here that those bubbles are actually, there's so much energy in there that they're actually eroding the stainless steel. So little miniature explosions, and there's millions of them coming off the propeller. And the faster you turn the propeller, the more bubbles you create, the louder it is. So that's where most of the noise is coming from. So what are the implications of all this? So we've got all kinds of intentional noise in the water, we've got unintentional noise in the water, and there's a lot of implications for the sea life. Some species will stop reproducing if it's too loud. Some species have a hard time finding food, listening for their prey, or using echolocation to find their prey. Some species will have a hard time with their social cohesion, calling back and forth to each other. A prime example of this would be a mother and her calf whale trying to talk back and forth. You can't see very far underwater, so they have to rely on sound. And if you can't hear each other over the background noise, then it's easy to become separated. There's also displacement from habitat. So if you have chronic loud noise in an area, fish species will move out, and that includes commercially viable fish species as well. So that can have a big impact on our economy. And then finally, if the noise gets loud enough, you can cause injury. You can cause temporary hearing loss. You can cause permanent hearing loss if it's even louder. If you go to the extreme, like some of the high intensity sonars and pile driving of steel piles, you can actually rupture tissue and cause death. And pile driving, you can see a lot of fish floating up dead from that, from those kinds of endeavors. So who's looking at all this noise? Well, there's a lot of us working on this. It's not just a single person, it's a whole group of people all over the world. And there's governments involved, there's universities involved, even landlocked universities are involved in this. And then there's a lot of really good non-governmental organizations. And I want to focus just on one in particular that I happen to be working with, and that's the BC Coastwide Hydrophone Network. And it's made up of 3 of the NGOs along the coast of BC, the North Coast Cetacean Society, and they operate in this area here. This map is on its side, so it's a little not quite normal if you look at north here. So Alaska up north is on the left side here. Washington State is on the right side here. Vancouver Island, Vancouver's over here. So up in the North Coast, we have the North Coast Cetacean Society, and they've got this really fancy hydrophone array here that allows us to track exactly where the animals are making their calls in Squally Channel. This is up by Hartley Bay. They also run the Central Coast area around Bella Bella, and there's 5 hydrophone sites there. We use some AMRs and some IC listens there. And these are autonomous ones. You put the hydrophones in for 2 months, go out there, collect the data, throw them back in for another 2 months, whereas these ones up here are real time. Everything's radioed back to the lab. Orca Lab at the north end of Vancouver Island in Johnston Strait, it's all real time as well, radioed back to the lab. So where they have researchers looking at or listening for the calls continuously 24 hours a day. And this is at a choke point for the water that's flowing into and out of the Strait of Georgia, and it's also a choke point for the ships and the whales. So it's a really valuable place to be monitoring, and it's highly active as well with the whales. And they've been running for about 50 years, so it's pretty impressive and valuable, the data sets that they have. And then down south, we have CIMRES, the Saturna Island Marine Research and Education Society, and they're at another choke point. This is in Boundary Pass, where all the water and the ships and the whales all have to funnel into the southern end of Strait of Georgia. And so it's another very, very important site to be monitoring. And these 2 groups are monitoring in real time. And then you have the Alaskan Marine Highway that comes up all through here, and so past all of these hydrophones. So they're all really well situated for monitoring vessel traffic as well as whales. So that's the hydrophone network, and the way they gather their data is with hydrophones. So this is an example, a hydrophone here. This happens to be an IC Listen hydrophone by Ocean Sonics, a Canadian company. We also use Jasco AMR's hydrophones, another Canadian company. It's kind of cool because 2 out of the top 4 hydrophone companies in the world are Canadian. So we put them on moorings, we put them in a shroud to protect them from the flow and the animals, and then we have this really expensive underwater cable that we put out to take the data from the hydrophone up to the shore, and then from there we radio it back to the lab so we can listen in real time. And I'll give you a short little video here. There's no sound in this video of us doing an install of one of these things, and then the divers checking out a couple more sites. This is around Orca Lab. So this is Susie. She's a research scientist from Orca Lab, and the lady holding the camera is Megan, another scientist working at Orca Lab as well. And this is me getting a hydrophone ready. So we work off of small boats like this. Whoops. Seems to have stopped here. There we go. And as we're deploying them in the water, we often use divers to try and make sure that we get them situated correctly on the seafloor. And you can see a bunch of different. This video is not working very well. A bunch of different sites in different topography or bottom conditions. Lots of sea urchins on these 2 particular sites. Okay, I think we'll leave that video aside, but you can see how they look underwater, and then the cable streams off to the side. Now, the data we collect, you can listen to it, or you can view it on something called a spectrogram. So this is one particular spectrogram, and not particularly exciting or anything, but it allows me to tell you a little bit about what you can learn from these sounds. So a spectrogram is just a plot of acoustic sounds, and so there's time across the bottom, and up the side here on the vertical axis is frequency. So this one happens to be going from 0 to 130 hertz, and the color gives you the intensity of the sound. And you can see that there's a really strong line here that's persistent in time here, and that happens to be at 60 hertz. Now 60 hertz is where we do most of our electrical power generation, So we know that this vessel has a motor and a generator set on the boat that's running and generating 60 hertz power for that vessel. And it's a really strong line. So this vessel is radiating a lot of energy at 60 hertz. So more than likely, this is an older boat, and it has its motor generator pair bolted directly to the hull, so it couples really well to the water and puts a lot of energy. Down here, we see a whole bunch of, a little hard to see, but there's some evenly spaced lines going all the way up to the sixth one here. I won't go into the details of how to analyze this, but this tells me that this is a large vessel with 2 propeller shafts on it. And each propeller has 3 blades on the propeller. And if I look over at the frequencies on here, you can calculate that the shaft rate of those propeller shafts is about 200 RPM. And a large vessel like this generally runs at about 10 RPM per knot. So that means this vessel's running through this area at about 20 knots. So a lot of information. You can, if you look in more detail, you can actually determine how many cylinders are in the diesel engines on these boats, and etc. Lots of information. And so from this, I can sort of say, yeah, it's in a choke point in Boundary Pass. He's running really fast through this area, so this is probably a container ship or a car carrier. Okay, lots of information. So I'm going to wind up here now. But before I do, I'm going to give you a little quiz, 2 little quizzes actually, that will help show you the impact of shipping noise on the marine animals. So this is a little quiz on something called masking. Masking is when you're trying to talk and there's loud sounds and it's too loud for you to talk over and it impedes your ability to communicate. So here in this particular site, we have a hydrophone in the water in Boundary Pass. There's a shipping lane 2 kilometers away from the hydrophone, and there's a container ship in that shipping lane. And there's a cetacean, a whale, about 1 kilometer away. So it's halfway between the ship and the hydrophone. So I'm going to play this little clip, and I want you to see if you can, can you hear the whale over top of the sounds of the vessel that's even farther away? And if you can, take a guess at what species it is. So here's the clip. The younger ears in the audience will probably have a better time picking that up. But that was an orca making that call, and specifically it was a J-pod orca. And if I filter out the boat noise from that and just play the whale call, this is what it sounds like without the boat noise. That yeehaw, that's a very, very specific call to just this family group, J-pod. So we know who that is. Okay, so here's the last exercise. This is a different vessel and a different cetacean. So this is a passenger vessel. It's in the same shipping lane, 2 kilometers away from the hydrophone. And I'll play this clip and see if you can figure out which species of whale this is. Okay, I won't give you much time to guess because I can't hear your answers. So that was a humpback whale. It was not this specific humpback. That's a picture I took at a different location, but it is a humpback whale, and this is what it sounds like when you filter out the boat noise. Now it's harder to do at the lower frequencies, so it doesn't sound quite as good, this one. So that humpback call, that ooh, is what you're hearing. And as you can see, in both cases, it's really hard to hear these whale calls over top of the background vessel noise. So it gives you some indication of the impact that we're having on these animals. Okay, so with that, I'm going to end it there, and hopefully I'll take some questions. Peter, did you want me to stop sharing the screen?
Why don't you leave that up there for a few minutes, Tom? Make sure that people can get through to you if they've got other questions or they want to get in touch. And
Okay.
start. I think we'll start the conversation now. So we have panelists, obviously, but we've also got a whole bunch of people in the audience. So please type your question into the chat, and I'll read it out. I'll share it with Tom, or I'll invite you to share it. We're getting a lot of comments that people could not hear the whales. So yeah, a very, very instructive quiz or challenge there, Tom, for all of us. A question here for you. What species are most vulnerable to noise in your view? Is this basically all aquatic species that we should be concerned about in terms of noise impacts? Or can we really do triage on different species groupings that may be particularly vulnerable to underwater noise? Any thoughts on that, Tom?
Yeah, well, certainly there's an impact on almost every species. That much is clear. But some species are more susceptible to others. For example, the endangered southern resident killer whale population is certainly heavily impacted by noise. This picture that I have on the thank you screen here shows an orca and a salmon, and they actually emit a sonar click in their head, and they focus it out the front, and they're looking to find the echo from the small swim bladder in the salmon, which is only about the size of your thumb. And they're trying to listen to an echo from something the size of your thumb at 200 meters. And so it's a very, very faint sound. And that's what they use to find and also hunt their prey. So if there's a lot of ship noise in the area, especially in the frequency band that they use, which is up around 45 to 55 kilohertz, then they have a hard time finding food, and it can reduce the volume of water that they can explore. And as a result, they have a harder time foraging for food. And that has a pretty big impact on them. And Lance, who's been doing some work on this, who's on, I think he's one of the listeners here now, so he's been looking at trying to estimate which of these whales are malnourished. Are they getting enough food? So it's certainly a particularly bad thing for southern residents, orcas in general, and there's other animals that are impacted as well, though.
Thanks, Tom. We've got several that are somewhat related. I'm going to try to merge a couple of questions here. So the simple question is, what changes in noise have we seen since COVID-19 has emerged on the horizon? Of course, that's been fairly topical in the news. And from Valeria, she weighs in by saying, you played a great bubble net feeding call. You think hearing the bubble net feeding calls that have not been heard before may have something to do with the COVID-19 caused reduction in shipping noise this year. So there you go, Tom. Have we seen any changes in coastal BC? And if so, might that explain the bubble net feeding calls that have emerged?
Well, we've certainly seen changes in the soundscape. So with less shipping, there's less noise, and there's been a couple of scientific papers that have been published already and more in the works on that. So it's certainly topical right now, and we'll be analyzing the data from this for years to come. With respect to that specific bubble net feeding call that Janie recorded up in Squally Channel, no, I don't think that has to do with COVID. She's in a pretty pristine environment there. There has been a reduction in the number of passenger vessels going past that site, but it's a pretty quiet site anyway. So I think that there's just this is a new call, whether it's new whales moving into the area or whether it's similar whales that have been there and they're coming up with a new call. I don't know. That's a question for the biologists, whereas I work more on the physics of sound propagation. So good question for Janie, though, that one.
Great. Thanks, Tom. Here related, people are looking for solutions and curious about solutions. And I've got one question here. Is there a simple but effective thing that a ship can do to reduce noise? And might this involve speed?
Certainly, yeah. So let me put this in a little bit of perspective. I started my career in the military hunting submarines, and the U.S. Navy in particular has spent many, many billions of dollars on making their submarines very, very quiet, and all warships for that matter are there's a lot of money invested in making those vessels very, very quiet. So actually, I'm going to show you a quick little plot of some data that we collected on various vessels here. So this is a little plot that I put together. It's based on the data from the ECHO organization at Vancouver, Port of Vancouver, JASCO, and ONC and Transport Canada all helped on this. You can see the Navy vessels here. This is sound intensity on the left-hand side. The quietest vessels are operating around 160 dB. That's pretty quiet. It's still noisy, but it's pretty quiet. And then you can compare that to other vessels which are operating on average above 180 dB. So that's about 100 times more. It would take 100 of these quiet Navy vessels to equate to an average container ship, for example. And the noisiest vessels up here are operating at over 200 dB, so that's 10,000 times. It would take 10,000 of these Navy vessels to equate the same energy coming off of one of these noisy bulkers or container ships, for example. So the point I'm trying to make with that is that, yes, there are technologies out there to make these vessels quieter. And they can be applied, and the navies are starting to release some of these technologies to the commercial world, which is great. So yes, vessels are getting quieter, and there's lots more that we can do to make them a lot quieter. And specific to the speed comment is, yes, that's a very, very valid comment. Port of Vancouver has been undertaking some trials with reducing vessel speed in their approaches to the port, and it has turned out to be very, very effective. And so those speed reductions will be implemented going forward as well.
Interesting. And you also mentioned some other solution-oriented propellers and things. Is there a sort of a best practices list for things that vessel operators or owners can do to make their own existing ship a little bit quieter? Things to pay attention to.
Yeah, so this is a spectrogram that shows a small boat. This was a 6-meter recreational boat going by, and it's insonifying all the way up to 100 kilohertz. So this boat is really noisy, and it's affecting every single species in the water, right up from the high frequency dolphins and porpoise down to the lower frequency baleen whales. And the Vancouver Aquarium has put out, and Oceanwise, I think, has information on this too. You'll have to correct me if I'm wrong, but that there are some guides out there for working with the whales, and also or in the presence of whales, and also how to operate your vessels. One of the biggest things to do is operating below the cavitation inception speed of your vessel. So as I said, with cavitation, the faster the propeller turns, the more it cavitates. But there's a point at which the propeller won't cavitate if you're going slow enough. And so if you can keep your boat below that, you generate a lot less noise. So speed is one of the easiest ways to tackle this problem.
Very interesting. Thank you. Question here from the audience. Adam asks, are the hydrophones set up for mammals or for shipping, or to what extent can you get biological sounds from the reef with fish, invertebrates, etc.?
Right. So that's a less of an important question these days than it used to be. But it used to be we had to be very specific with how we designed our hydrophone moorings and our hydrophones in order to target the type of sounds that we wanted to record. Um, but nowadays, these IC Listens and AMARs, they are such phenomenal pieces of gear that we can use the same hydrophone to capture really, really quiet sounds when the ocean is at its calmest and quietest to really large vessels going really close to these hydrophones. And they can capture that full wide dynamic range of intensities. And they can also capture really wide ranges of frequencies. And so our technology is so good these days, we can use the same hydrophone to actually capture all kinds of different areas and types of sounds. So it's less important within the sort of last decade than it used to be. But you still need to tailor your stuff. If you're going into high flow areas, for example, if you have some of the reef systems that we have in BC here are they develop in high flow areas because there's lots of nutrients flowing past, so it's advantageous for the animals. But it's hard on hydrophones, and so putting those shrouds on the hydrophones is a good way of making your hydrophones work to collect data in those kinds of environments.
And Tom, you talked about monitoring, and obviously the data that you're sharing with us today reflect an ability to understand the noise in the context of the water column and also biota. Are there other applications for this kind of monitoring? For example, could enforcement, fisheries management, fisheries enforcement take advantage of using hydrophones to understand what vessels are in an area and/or what sorts of activities they might be involved in that area?
Yes. So one of the things that can be used for enforcement is detecting drug smuggling. For example, the RCMP or the Canadian Navy, U.S. Navy does a lot of that too, and they can find submarines running drugs or surface vessels running drugs that way. And another one is trying to detect people that are going into marine protected areas or sanctuaries illegally. So I've been doing a little bit of work with the Simres hydrophones, looking at small vessels, and using the acoustics, we've been able to detect the vessels in the area. And even with single hydrophones, we can get, in some cases, a range from the hydrophone to the vessel so that we can tell whether or not that vessel's actually infringed on the marine protected area. You can tell, in some cases, what the speed of that boat is in there. So if there's speed restrictions in a protected area, you can pull that out of the acoustic information. And oftentimes you can tell the type of boat as well. You can tell whether it's a displacement hull like a tugboat or a planing hull like a speedboat. You can tell a lot of information about the vessel itself, and if we really get good at this over time, we'll actually be able to tell which boat it was. So we've got a long way to go on this stuff, but there's a lot of other uses for this sort of technology.
Thanks, Tom. You have a fan here in the form of Sarah Patton from Victoria at our OceanWise office there. She says, we do a lot of presentations that include noise components, and you have some really great slides. Would you be willing to share any of your slides with credit and/or sound clips to use in these educational programs for boaters?
Yeah, sure. You can go to Ocean Networks Canada and download all of their stuff for free. You just have to mention their name. And all of these NGOs that I'm working with the BC Hydrophone Network, they all want to share their data. So yeah, you can certainly ask for all kinds of data sets from them directly. And certainly for my slide deck, you're more than welcome to share this. I have no problem with that. There are some of these files, like this one I have up on the display right now, is from Simres, so you should credit them with that if you're going to present that anywhere. Same thing for for North Coast Cetacean Society or Orca Lab. But yeah, no, I think it's great. The more the better.
Thanks, Tom. So looking at where we are today with hydrophones, their placement, the number, the technology, perhaps if you could reflect on the future and how well positioned you feel the coastal British Columbia is to sort of understand and monitor the underwater noise as we look ahead, and whether there are any significant gaps or opportunities that you might want to share with us on the road ahead. Are there, if a high level panel from Ottawa said, Dr. Dakin, give us some advice. We've got some money and we want to know what your priorities are for noise in British Columbia in the coastal region. What would you advise? What would you say? Would you say we got it covered, or would you say we're holding it together, but we need to do A, B, and C?
I would say things have really kicked off in the last sort of 5 years or so, maybe 10 years. And all of a sudden, we're realizing how important underwater sound is. And so we're on a mad race to try and improve all of our systems along the BC coast. DFO's got systems in the water. Parks Canada has systems in the water. The NGOs, Ocean Networks Canada, DFO. So there's lots of people with hydrophones in the water, and we're all trying to improve. It's a hard thing to do, putting in things into the ocean environment. The waves pound things to pieces. The salt water is corrosive. The pressures are enormous. It's hard to work in this area, but there's a lot of people working on it. Unfortunately, it costs a lot of money, so we don't have anywhere near as many hydrophones along the coast as we would like. There are certain areas, like Janie and I were talking this morning about Verney Pass or Verney Channel up near Hartley Bay, where she said she could count 50 whales just sitting in her boat in one spot, 50 humpbacks. So that's a prime habitat usage. So we need to get some hydrophones up there to understand how they're using that habitat. Another around Klemtu, for example, we don't have any hydrophones there, and it's known to be a real hot spot for whales. So there are lots of gaps in where we have hydrophones. There are probably the biggest single gap we have is in our ability to analyze all this data. I've said many times to people, there simply are not enough acousticians on the planet to look at just the hydrophone data from BC. So there's no way we're going to be able to look at all of this data. So we need automated tools. And there are companies like Jasco and Google and Chipley Systems that are, and Ben Hendricks is working for North Coast Cetacean Society. There are people working on this problem, but we've got a long, long way to go before we can do automated data sets in real time for all of our hydrophones.
Great. Thanks, Tom. Perhaps a related question here. How long do you expect it to take for hydrophone networks in British Columbia are and therefore accurate enough with regard to triangulating and pinpointing whale location and directionality within 3 nautical miles?
I missed that last part. Peter, can you say that again?
Triangulation to pinpoint whale location and or directionality within, say, 2 nautical miles.
Right. So we're doing pretty well already. Ben Hendricks' work in Squally Channel with those 4 hydrophones up there, he's able to locate whale calls to within 100 meters of that whale. So this is phenomenal because it allows us to map out which habitat in the area that those whales are using. So the big question is can we get Ben's software working on all of these other sites? And so I'm in the process of trying to upgrade the hydrophones along the coast so that we can use software like Ben's or Jasco's or Chipley Systems to localize those whales and track them Ben software is pretty cool because you can look at a specific track of a whale as it's moving through an area making calls, and you can see the track of that whale in almost real time. It happens with about a 5-minute lag. So we'll get better at this, but it is pretty exciting, and it's almost here along the whole coast. We'll get there within probably 2 years.
Great, thanks. From Lance here, you mentioned that technological improvements have made it possible to pick up very quiet sounds. Are these due to hardware improvements or software? That's the first question. And the second question is, what holds back further work? Is it money or technology impediments or other aspects?
Well, resources are the biggest impediment. In terms of the technological improvements to get down to really low noise conditions, that's primarily hardware that has allowed us to do that. The software is another really cool thing. It allows us to dig deeper into the noise to pull out whale calls. So we're hearing whales at distances and in noisier conditions than we've ever been able to before because of software. But the biggest thing is reducing the self noise of the hydrophones themselves, and that's a hardware issue. So there's some really cool guys out there like Jay Abel at Ocean Sonics who are just whizzes at being able to make these things operate with very low self noise on the hydrophones. Hopefully that answers the question.
Interesting. We're running a little bit low on time here, Tom, but I think we've got time for 2, maybe 3 other questions. And I've got a nifty one here. Does the sound energy of some of these noise sources actually contribute to localized warming of ocean water? Might be a little bit outside your line of expertise, but it is an interesting one nonetheless, because of course noise is energy.
That's right. And so the physicist in me says that yes, if you're pumping energy into a system, it's going to increase the temperature. But is it measurable? No. So it's not something that we really have to worry about.
Okay, thanks, Tom. From Katie online, can you touch on these military technologies that are used to designed to reduce noise? So how can the Navy do it, and can the cargo vessels learn, or the ferry vessels learn from what the Navy has done to make their ships quieter for different reasons?
Yeah, there's all kinds of technologies out there. So one of the best things to do is not so much the technology on each of the vessels, but is just maintaining your vessel. So when you're running through the water, you quite often get ropes and stuff wrapped on your shafts, and that can cause something called shaft rub, which is really loud and obnoxious. And all it takes is to send a diver down and cut those ropes off your shafts. So that maintaining your vessel, cleaning the barnacles and stuff off your hull, cleaning out the dings and the nicks in your propeller, all of those will make your vessel quieter. So that's the first step. The next step is vibration isolation from your hull. For some of the motor components and machinery that you have mounted, that can help reduce the noise signature of your vessel. And probably the most important are the different technologies to do with your propeller. And those, the best ones out there are classified top secret by the navies, but there are some that have been out for a long time, and we certainly know about. And one is adding more blades to your propeller, and longer blades, so that you can get the same amount of thrust out of your propeller, but at a much lower shaft rate. And that helps reduce the cavitation and therefore helps with reducing the noise. And there's other things like shrouds around the propeller to reduce the cavitation. There's hub devices that can be added to reduce some of the cavitation behind the propeller hub. So there's lots and lots of little technologies, and you can go online and look up, see images on Google of all kinds of different types of those technologies.
Well, thanks very much, Dr. Tom Dakin, today. The Conservation Technology Award. So thank you so much for sharing your insights in a remarkable forum and format. So thank you, Tom, and thank you for the audience questions today. We had terrific back and forth. There are, I think, outstanding questions that we were unable to get to, but I think Tom would be happy to respond by email. But thank you to Danica and to Amanda for enabling the session today. Thanks to Tom for his talk, and thank you to the audience for joining us on this wonderful day. I'd like to remind everyone that this time next week, Thursday at 1 o'clock, we'll be welcoming Alejandro Fid as he accepts the next Ocean Award for Conservation and Research Communications. So that's a little bit more of a media talk in terms of communicating around the issue of ocean conservation. So the journey continues. Thanks, Tom. Congratulations. We're humbled and delighted to have you as part of our family now. And we look forward to more engagement. And please accept our best wishes for a productive, healthy, sane, and delightfully interesting life on your journey around ocean noise. So thank you, everyone. Take care, and bye.
Thanks, Peter.
The main.
Bye-bye.